Hello everybody, and welcome to Calculus in Flight Planning by Pranay. I'm going to show you how calculus is used in flight planning every day. So, how many planes fly per day? Well, it's 100,000 planes that fly around the world every day. You have to think to yourself, how do all these flights get to their destinations? How do they take the right path? How do they have the exact right amount of fuel? How do they have the correct altitude? This is all through calculus. So, who uses calculus in flight planning? Which jobs actually use calculus in flight planning? So, the jobs that use calculus in flight planning can be flight planners, aircraft fuelers, and aviation engineers. These three jobs all use calculus in their own ways, but it's all to get the plane from the start to the finish. There are some other uses of calculus in aviation that isn't necessarily in flight planning. There's space navigation, where they do trajectory calculations and orbital mechanics. And there's also aircraft performance, where people analyze forces, pressures, and airflow to design safe aircrafts for everyone to use. What type of calculus is actually used in flight planning? Well, there are two types of calculus that are used in flight planning: differentiation and integration. In differentiation, optimization is used in flight planning the most, with optimizing different things. Integration, which is also inverse differentiation, is also used for multiple things in the whole realm of flight planning. How does calculus actually assist in flight planning day to day? Well, optimization, differentiation, is used to find the amount of fuel needed while keeping distance constant. They need to go the exact distance of, let's say, 2,000 kilometers, and people need to find how much fuel they need for that so they can use calculus. Now, in integration, you can integrate functions of speed or rate of travel, and that can find the distance traveled and the total time required for a flight. That can be used for estimated times of arrivals and other things. Integration is also used to find the altitude of a plane throughout all the time of flying. Now, why is calculus used in flight planning? Well, optimization uses rates of change and overall behavior functions well, and it has an amazing ability to capture the dynamic structure of real-world problems. Integration, on the other hand, is very accurate in determining distance and velocity changes, and it aligns with physical principles of dynamic systems. Now, what are the advantages of using calculus in flight planning? Why wouldn't someone use another method of math rather than calculus? Well, calculus is well suited to handle variable rates of change, and calculus makes accurate predictions of distance and time. Calculus is also really consistent with lots of physics concepts, and calculus can provide precise trajectory analysis of planes. The optimization algorithm is through calculus, so optimization has to be through calculus. Now, what methods of calculus are used in flight planning? We know that optimization is used, we know that integration is used, but what are the methods? Optimization uses differential equations to find the maximum and minimum of a function, and using that, you can optimize the amount of one variable while keeping the other variable constant. In this case, keeping distance constant while trying to optimize the amount of fuel. Integration is the inverse operation of differentiation and is used to find the total net effect of a continuity or continuously changing quantity, or to determine the antiderivative of a function. Thank you everyone. This was Calculus in Flight Planning by Pranay.